Hello everybody, today we will be talking about truth table. This is part 2 of the logic section for geometry. So last time we talked about the truth table as an introduction, and we talked about also how to deal with the and statement or statement, and also I think the negation statement. So we're going to build off of that right now. So this time I'm going to go ahead and teach you a new operation that we can use for two or more statements. So this one is going to be called conditional or if and then statements. So here I listed out all the things that we're going to be looking at for today. The first one we're going to look at is the statement if P then Q, which is written as P and then with an arrow of a Q. So the way we usually say that in general is P implies Q. Okay, so let me kind of write that out. P implies Q. Okay, so let's go ahead and jump into it then. So first of all, the definition P implies Q means if P, then Q. So here's an example of the to put into action. So let's say the statement P is going to represent you get an A in geometry. And then Q is going to be the statement Mr. Chan will take you to Disneyland. So if I say P implies Q, then that means the following. If you get an A in geometry, then Mr. Chan will take you to Disneyland. So you can see each part as is written according to the expression that's on the left-hand side. So the first statement is an if statement, and the Q, what it implies is going to be the result if that statement actually happens then. Okay, so hopefully that part is pretty straightforward. Now, what I would like to do though, just to make it a little bit more complicated or more complex, is to look at the truth table behind it and how does that work out with the stuff that we did from yesterday or last time. So here, let me go ahead and draw the truth table, and then we can go ahead and maybe dissect it and see how this will work out then. Since we have two statements, P and Q, then that means that we have four different scenarios of true or false, just like last time. So it could be the case where it's both true. Could be the case where one of the statement is true and the other one's false. There are two of those scenarios, TF or FT. And then there's also the last case where both of the statements is going to be false. And I would like to look at all four of those cases and see how does that work with this if then Q situation. Okay, so here we go. Let's look at the first one over here. And let me go ahead and use a different marker so you can see which one I'm talking about. So right here. Now, so here's how we're going to say this then. The statement P is true. The statement Q is true. So that means that, yes, you did get an A in the geometry class. And the statement, yes, you are going to be taken to Disneyland, or I'm going to take you to Disneyland, is also true. So now if I look at that P implies Q statement, if Mr. Chan, if you get an A in geometry, then Mr. Chan is going to take you to Disneyland. Think of it as a promise, right? Did I hold my end of the promise up? If you got an A and I did take you to Disneyland, so therefore I held up my end of the bargain. So therefore the statement itself is going to be true then, okay? Because everything is satisfied. The if statement is satisfied, therefore the then statement is satisfied, so everything is all good. You guys are going to Disneyland, great. Now, for the second one, here, it's saying that, hey, you got an A in the class, but you did not go to Disneyland because the statement Q is going to be false. So, in terms of did I held up my end of the bargain? Did I keep my promise? The answer is no. So this one is going to be false. So in that case, I'm basically a big liar because, you got an A, but I never took you guys. So I was basically lying to you. I did not held up my end of the bargain. Okay, next one is going to be a little bit more tricky. And the next one after that is a little bit more tricky too, but I think we can handle it. So this time around, here's what's happening. You did not get an A in the class, but I still took you to Disneyland. Let me repeat it one more time. The F right here implies that you did not get an A in the class, but I still end up taking you to Disneyland. The question then still remains, did I held up my end of the bargain? If you get an A, then I will take you to Disneyland. The answer to that is this is still true. The reason is I'm still holding up my end of the bargain. You just never met the requirement. Meaning that if you did get an A in did get an A in the class, I will take you to Disneyland. But you didn't get an A. So I wasn't lying to you, but I still took you to Disneyland regardless. Basically, I can kind of like tell you anything I want, and so long as I don't break the promise, then it's still okay. For example, let's say that if you get 150% in the class, I would go ahead and buy you whatever you want. There's no way for you to get 150%, but hey, I can still tell it to you and it's not lying until it actually happens and I break the promise. So for that reason, the if and then statement in this case is going to be true then, because the promise was made, I just never broke it because it's impossible to break it. And finally, for the last one, you did not get an A and you did not go to Disneyland. But keep in mind again the idea of a promise, right? If you did actually get an A, I would take you to Disneyland, right? Nothing is broken, no treaty is broken whatsoever. So this one is also going to be true then. Okay. So again, think about like how it works as a promise, right? Did I break my bond to you about going to Disneyland if you get an A? If you did actually get an A and I did not take you, then that's the only time that I broke a promise and therefore it's going to be false. But any other time, it's still going to be okay, right? So it's kind of like, I can tell you whatever I want so long as I'm not lying to you or so long as I don't break a promise then, okay? All right, so now let's talk about the converse of a statement then. So keep in mind, still we are looking at A being the statement, it is Friday, and B, oh, I'm sorry, I'm going to switch it up a little bit actually. The statement A is going to be represented by it is Friday, and the statement B is going to be represented as it is raining. So, just to kind of change it around a little bit. So over here, if I write what is A imply B, then that is going to say if it is Friday, then it's going to rain. And I literally wrote that out without even looking down a little bit right there, right? So that's the regular statement. Now, if I want to know what the converse of that statement is, well, that's this guy right here. B implies Q. And if I were to write that out, here's what it actually says. If it is raining, then it is Friday. Okay, so in terms of writing it out, it's not too bad. But now what I want to do more importantly is compare that to the original statement. The question is, are these two logically equivalent to each other? Meaning, do they represent the same thing? And if you think about it a little bit, they really don't, right? Because in one case, it says that if it's Friday, then it's raining. And then the converse is saying that if it is raining, then it is Friday. And it's not necessarily true, right? Because there could be other days that could be raining. It doesn't have to be a Friday. So there are some times that is true, sometimes it's not true. So this is what we're trying to figure out. If two statements are actually going to be the same thing, also known as logically equivalent. If you want to find out if two statements are logically equivalent to each other, the best way to do it is to look at their truth table and see how they compare. Well, we know how to build a truth table, so let's kind of go through this just to make sure that you understand it. We built a truth table for the regular if and then statement already, for A implies B. Earlier, from up here, if you remember, we said that these guys right here is supposed to be T, F, T, and T. Okay, the only one that's false is if I actually break the promise and I did not take you to Disneyland. So now I'm going to go ahead and look at the truth table for the converse, which is B implies Q. So that's what I really want to build. So over here, I'm going to go ahead and build that then. I'm going to go ahead and try to build B implies A. Okay. Now, in order for you to see that a little bit better, what I'm going to do is I'm going to go over here and take column A, and I'm just going to go ahead and rewrite it in front of column B, right? Just go ahead and rewrite it. So T, T, F, F. So then that way you can kind of see it a little bit better to work off of that. Next, what I want to do is build B implies A. So I'm going to look at B as the if statement and A is the then statement. So here, if you see T and T, right? The if statement is true, the then statement is true. So therefore, according to A implies Q, what I did over here earlier, this is going to be true. Okay, so that part, not too bad. Now looking at the next part, the if statement is false. The then statement is true. I did not break a promise. You just never made that. You just never met that condition. So I never lied to you. So therefore, that's true. Then I have the if statement is true. The then statement is false. So then that means that this is going to be false because I broke my promise. See what I did right here? Remember, I just took A and put it in front of B, so then that way you can see how the if and then statement works out right here. And you can always do that just to make it a little bit easier. That way you don't have to like look at it, read it from right to left instead of like just always from left to right. Finally, else and false. So this one is going to be true then. Okay. Now what I need to do is I need to compare this guy right here. Oops, sorry, don't want to erase that. So let me kind of write that one more time. Now what I need to do is compare the end result, right, over here and to my original statement over here and look at the two together. The first one has TFTT. The second one has TTFT. So therefore, they're not logically equivalent because they are not the same thing. Okay, so that's how you can show if two statements are actually going to be the same then. So in short, the converse, yeah, it's not the same as the original statement. Not always anyways. Now, the last part is something called the contrapositive. Negation of B implies the negation of A. So here, let me just go ahead and write out the statement according to what we had before. So then that way you can decide if it's the same or not. Remember, A is supposed to be, it is Friday. B is supposed to be, it is raining. So the negation of B implies the negation of A is going to be the following then. If it is not raining, okay, or you can say if it is not true that it's not raining, then it is not Friday. Okay, so that's the contrapositive statement of A implies Q. Oh, sorry, A implies B. Well, dissecting this a little bit, if it is not raining, then it is not Friday. Is that the same thing as the original statement? It sounds like it's exactly the same thing, right? Because if it is Friday, then it's supposed to rain. So if it's not raining, therefore it's not Friday. Yeah, that kind of makes sense. Well, let's go ahead and prove it just like we did before, just to make sure that you guys are seeing that, yeah, this is actually the same thing. So once again, I'm going to go down here and fill in the truth table. Here, the first one, that's set already. That's T, F, T, T. And we did that already. The next one, I'm going to go ahead and build the contrapositive table. Well, it looks like I need to build the following. I need to build the negation of B, right? And then, looking ahead, I'm going to need to build then the negation of A and use those two to finally solve for the negation of B implies the negation of A. Okay, so let's go ahead and fill in each part. If you have B and the negation of B, here you have T, F, T, F. So that means negation would be F, T, F, T, the opposite of that. Negation of A, we have T, T, F, F. So the negation would then be F, F, T, T. Now let's go ahead and use these two to go ahead and build what I want, which is negation of B implies negation of A. 2F in an if and then statement, that's going to definitely make this true. The T and then F situation, that's the case where it was supposed to be false because I didn't hold up my end of the bargain in the promise. F and then T, so that's going to be true because I still did not lie to you guys yet about breaking the promise. And then T and T, that has to be T because both if and then statements are satisfied to be true. Once again, we're going to compare that to the original, right, which is over here on the left-hand side. And you can see this time around, TFTT, TFTT. So yeah, these two are logically equivalent to each other. So therefore, the contrapositive is the same thing as the original statement. All right, so that should do it. Thank you again for watching. I will see